All right. Hi, my name is Hamzah Ahmadi, and I'll be talking about the second kernel in our fast Canny edge detection process. And that's a Sobel filter, or kind of like just finding out where the gradients are. So we start out by using this Sobel 3x3 kernel, and this just helps us approximate the gradients in the X direction and the Y direction, or horizontal or vertical. And these represent the first derivative of the image intensity at each pixel. So after we apply this, we get the gradient of the pixel in the X direction and the gradient for the Y. And then we use that to calculate two values, which is the intensity and the angle. So for the intensity, we just do the gradient in the X direction of the value squared plus gradient Y direction of the pixel squared. We do the square root of that, and that helps us find how strong of the gradient the pixel is. And then the second equation is for determining the angle. And this is used in a later kernel, which I'll talk about. So these two equations and this kernel you can see in our code. This is just the Sobel kernels, the 3x3s. And then we start out just by looping through the entire input matrix. Obviously just setting our registers, and then after we loop through the input matrix, and we compute for each value the gradient in the x direction, gradient in the y, and that's done mostly right here. So we just use a fm add instruction intrinsic for each pixel and store that in sum, and then we compute the pixel just indexing right here, and then after we get the gradient for each direction for each pixel, we actually apply the equation right here. So we pretty much do the same process, the square root intrinsic, add, and then multiply each pixel's direction, x direction and the y direction, so square it basically, and then add those two and square root it. And for finding the angle, um just use the mostly the arctan intrinsic for gradient x, gradient y, and then we just store the values. So that's pretty much it. And then after we loop through the entire matrix, some pixels are left over, which the any index that's kind of like not divisible by four at the end, the remaining indices basically, we loop through that as well. So we make sure everything gets covered in our matrix, and then this is kind of just like a good representation of you can see where so that like the red is basically kind of like the in between the not the edge and then also the edge. So these will have like a lower intensity, and then the middle's very much the edge. So that'll have a higher intensity, and then we're also looking at the angle. So you can have the angle be in just vertical, horizontal, or diagonal. So we're also looking at that. And then the reason we look at the angle is because we use that in the next kernel, which Jamie will talk about. Um, if the angle is zero, the point will be considered on the edge. If it's closer to 90, uh, it's more north and south. And then like about 135 is northwest, southeast, so diagonal. And then 45, same thing, that other direction of diagonal. So calculating the angle helps us in the next kernel as well. So Jamie will talk about that. Thank you.